Hello friends, welcome to this new set of videos on number theory. Number theory is going to be one more important branch of mathematics that deals mainly with numbers and in particularly integers. They have a wide range of application varying from the modern usage of the cryptographic technique where we will be able to decode or convert a word into a cryptic message and then it can be transferred, and divisibility theorem and other things have many of their application related to the coding theory and other parts. So we will see how we can enjoy the concepts of number theory through various parts of it. The beginning video will deal with permutation and combination. As such, we will see in this video of part 1 what is meant by permutation, what is meant by combination, what's the basic difference between them, and how we can apply them to problems based on their applications. Come on, we will move into the video. Permutation refers to an ordered arrangement of R elements of a set containing n distinct element. So the keyword over here is ordered arrangement. And what is meant by combination? It is going to be an unordered selection of R elements from a set containing n distinct element. So over here also it's going to be the same set, and here also the same set. The set has how many elements? N elements. And what we are going to do? We are going to pick R elements out of them. If the process involves just picking, then you call it by the name combination or combinatorics. Okay, combinations. Now after picking, if you are going to arrange them, that is, you are going to number them as first, second, third, fourth, and so on. If you are going to arrange the datas, then it will be referred by the name permutation. So what we see as such is a permutation of the object involves ordering, whereas a combination does not take into ordering. It is just the mere action of picking. So we can see that picking goes with combination and arrangement goes with permutation. It is going to be like AP and PC. P and P will never go with one and the same. So it is going to be the opposite way around. How to denote these elements? The permutation of n objects from R objects is going to be denoted by PNR. Out of n objects, I am selecting R object. So you can also call it by NPR. The combinations is denoted by NCR. Out of the n objects, we are selecting R objects, and that is also denoted by NCR or with a brackets an N and an R. So these are the three different ways of representing your combination. This combination as such can be represented by the formulae n factorial by n minus r factorial. So first we will see what is meant by factorial of a data. Factorial is nothing but product of consecutive integers starting from n and ending with 1. That is n into n minus 1 into n minus 2 into up to multiplied till 1. So if I have it to be 5 factorial, it is nothing but 5 into 4 into 3 into 2 into 1. As such, we can make use of the calculator to estimate the factorial of any given quantity. We need to keep in mind 1 factorial is 1, and we have a surprise like 0 factorial is also 1. So keep in mind the basic starting for your factorial is going to be 0 factorial is 1 as well as 1 factorial is 1. In particularly the value of Pn. So out of n, if I am going to use all the n elements, then it is going to be n factorial. That is, I have 3 objects which has been picked and I have to arrange all the 3 objects. Now in how many ways I can arrange these 3 objects? The first place can be arranged in 3 ways. Now one object has gone. The second place will be arranged in 2 ways and the second object has gone. And the third place can be arranged exactly in 1 way with the 1 left out objects. So it is 3 into 2 into 1. So it is nothing but your 3 factorial. So if you have 3 position and you will have to fill all the 3 positions, then it is 3 factorial. If you have n position and you will have to fill all the n positions, then the number of ways is n factorial. Now coming for your C of combinatorics part. So what is going to be NCR? It is NPR divided by NRR. So it is n factorial by r factorial into n minus r factorial. In particularly, we have the NCN value to be equal to 1, and we also notice that NCR is the same as NCN minus R, because the picking up of the n required object is the same as picking up of the left out objects. So how many of them is being left out? That is also going to be the same number of ways in which you can choose an object for. Okay. So now you need not have to worry. This is going to be very computationally a tedious task, because we will be allowed to use calculators in examination, and we can just use the NPR and our NCR buttons, which are present on top of the multiplication and division symbol in the calculator to easily obtain our answer. This calculation purpose, we will see it entirely in a different video. Please watch for it. Okay, now we move on to something called as a product rule and a sum rule. That is, say suppose we have an activity. Now this activity has been broken into too many steps. Step 1, step 2, step 3, step 4 and so on. So I need to perform all of them, A and then this B and then this C and then this C. Only then the task is going to be complete. So this entire task has to go through 1, 2, 3, 4 steps, and in hence what is going to be the total number of ways this activity can be performed at? It is going to be the product of all these ways. So it is going to be N1, N2, N3, N4, the number of ways in which I can perform task 1, task 2, task 3 and task 4. So the entire of the bigger task, which has now been broken into it, will be the product of N1, 2, 3 and 4. Keep it in mind, whenever we have the AND operator, the symbol to be used is going to be multiplication. So AND operator always goes with multiplication. Please keep this in your mind always. And in a similar way, what happens with your OR operator? Your OR operator always goes with a plus sign. So whenever we have the OR operator, you will be adding up of the data, and whenever we have AND operator, we will be multiplying the data. So what is about addition of the data? Now that is called as the sum rule. If you have an activity which can either be performed by the first way, or you can have the second way to do the same activity, or you can have the third way to do the same activity and so on, then this activity can be performed by either this or this or this or this. So you have N1, N2, N3, N4 connected with an OR. So if you have an or in between, then what you will have to do? You will have to add all the data to get the total number of ways. This is what we call as sum rule and product rule. So for the product rule, individual value is broken into n number of components, and hence the final value will be multiplied for. In the sum rule, the individual value is either performed by one of these activities, and hence it is going to be added up for. Next, we have the permutation for repetition of objects. If we have identical objects to be repeating itself, then what you do is you do the total factorial and divided by the number of times the values is going to be repeated for. Say suppose I have the word called as P-E-P-P-E-R, pepper. In how many ways can I arrange the elements or alphabets of the word? Arrange the elements of the word pepper. So I know that 1, 2, 3, 4, 5, 6. 6 different ways I can arrange it. So I can have totally that to be arranged by 6 factorial ways. But I notice that out of these elements, there is going to be repetition of the letter called as P. So if I am going to fill this with the first element called as P, this P can either be one of these 3 elements. So that has to be eliminated from the total evaluation. So what do I do is, the number of times P appears is going to be equal to 3 times. So I divide it by 3 factorial. And I notice that the second letter E appears how many number of times? 2 times. So I also divide it by 2 factorial. And the last one is going to be your R. Your R appears how many times? It is going to appear 1 time. So it is going to be 1 factorial. Okay, so what do we do is we compute the total number of computation n factorial, and then we see how many times the objects are getting repeated, and then we divide it by the number of appearance of the elements. So obviously 1 factorial being 1, we ignore it, and normally we go for only repetition that happens more than once. So that will be the final answer for our number of ways of arrangement by the word called as pepper. You can try enjoying the same for the word called as entertainment. Just check entertainment, how many elements it has, how many times E repeats itself, N repeats itself, T repeats itself, and so on. You can just divide it by the number of time of repetition of it. That will give you the number of ways in which the words or the alphabets of the word entertainment can be arranged for. Now coming to the last part called as circular permutation. Now we have been seeing about arranging objects along a straight line. Now instead of a straight line, the elements are being arranged along a circle. Then what will happen? In a straight line, the starting point and ending points are going to be different. But when it comes to a circle, the starting point and ending point happens to be the same, and hence there is not going to be any distinction between start or end. Therefore, the number of ways in which you can arrange n objects will be n minus 1 factorial. Notice when we arrange them in a straight line, your n objects will be arranged in n factorial ways. But when you arrange it along a circle, the same n objects will be arranged in n minus 1 factorial ways. This minus 1 happens because the start and end points are going to be the same. Now, in particularly, if we are not making any distinctions between clockwise and anti-clockwise arrangements, then the number of arrangements can still be reduced by half. So, number of arrangement, if you have no distinction, that is, you don't consider clockwise and anti-clockwise to be different, that is A, B, C to be different from that of your A, B over here and C over here. So what happens over here? one moves clockwise, the other one is going to move anti-clockwise. So the element is in the position CAB, but over here the elements are positioned in the back way around. So if there is not going to be distinction in it, both of them are going to be the same, because A has the neighbor to be B here and C here. Again here also A has the neighbor to be B here and C here. So if no distinctions are made, then the number of arrangements will be n minus 1 factorial divided by 2. So keeping all these basic things in mind, we will try to solve problems on permutation and combination in our next video. So keep on watching. We will see how easy we can make permutation and combination for you people. Thank you.